Okay, so this video is going to be designed to help specifically those students that are having trouble solving for a variable. And I spent a lot of time thinking about it. Why is it that this is such a hard concept to grasp? And when I started analyzing it, I came up with some reasons why students have a hard time, and actually they're understandable. So let me go ahead and show one example here. And what we're doing is we're solving for the letter x. We're trying to get x by itself. Okay, so the first rule that we need to come up with is always undo addition or subtraction first. Always undo addition or subtraction first. So in order to solve this, we have to figure out which one of these numbers here is being added or subtracting to the x. Okay, so when we say solve for x, we're meaning it should be x equals. That means there should be nothing else on the same side of the equal sign as x. That's what solving means. Solving means you get a letter isolated and by itself. And so if I say solve for x, I have to get rid of both this -3 and this +5. But the order I do it in matters. Okay, so what would I get rid of first? Would I get rid of this 5 or this -3? Well, since we're always undoing addition or subtraction first, we need to know which one's being added and subtracted to it and which one is being something else being done. Okay, so how do we know? Well, let's start with this -3 next to the x. If you look at this -3x closely, you have to see what's in between them to see what's being done. What's in between the -3 and the x? Well, if it were being added, it would be a -3 plus x. And there's not a plus sign. So it couldn't be that. If it's being subtracted, it'd be x minus the -3. Well, so there's not an addition or a subtraction sign. Or you could do a -3 minus x in between. And that's not in between either. What is in between the 3 and the x? Well, there's nothing in between it. If you look, there's nothing in between the -3 and the x, right? So if there's nothing in between, the default operation in algebra is to multiply. This -3, even though there's a negative, is not being subtracted. It's being multiplied by the x. Or you could say it the other way. The x is being multiplied by a -3. So if that's being multiplied, and we always want to undo addition or subtraction first, what's the 5 doing? Well, there's a plus sign in between the x and the 5. So it's being added. So we have to undo the adding. And how do we undo adding? What's the opposite of adding, right? What's the, if you want to use the math terminology, the inverse operation of addition, right? Well, it turns out that it is subtraction. Let me go over that real quick. We'll come back to that problem. What are the opposites? So the opposite of addition is subtraction. And let me prove that to you. Let me give you some evidence of that. If I had 3 plus 4, it would equal 7, right? That's adding. So let's do the opposite of that. Let's do a 7 minus 4. If I do a 7 minus 4, I will equal a 3. So adding it, 3 and a 4, I get a 7. Subtracting 7 minus 4, I get a 3. They're opposite functions. You get the same numbers. It's just going in reverse directions. So the opposite of addition is subtraction. What's the opposite of subtraction? Well, it's the same thing. It's addition for the same logical reasons. What's the opposite of multiplication? Well, you could say, well, addition and subtraction have already been took, so it must be division. Well, you're right, and I can show you. 3 times 5 equals 15. So let's do it the opposite way. What is 15 divided by 5? it equals 3. So going one way, you get 15. Dividing the other way, you get the 3. So they're opposites of each other. Okay, so that's very key to doing algebra. And so by the way, just so we can review this, I have it here. Adding looks like a plus sign. Subtracting looks like a minus sign. Multiplying, you don't have to have anything in between. That's multiplying. Or you can have parentheses. You could do like a 3 times x. That's also, I'll put a comma between. That's also multiplying. Or I could have a negative 3 times x. Even though there's a negative, it's still look in between. It's still multiplying. So there's lots of ways to multiply. Now division we think of is like long division, like this symbol, the bar, or like this. But in algebra, in division, we usually just write it as a fraction. So if I want to divide, I would just put a fraction under it. 3 divided by 5. X divided by 7. So in algebra, when we're dividing, we're often just using this fraction bar and not what we're used to seeing, this, or sometimes we'll use a sideways slant. But no, we're just using the fraction bar. So, okay, we went over a lot of rules. Let's work out this problem now. So, we always want to undo the addition or subtraction first. And we're trying to get this x by itself. So this is being added. Look, it's between the x and the 5. You always look in between. And it's being added, so you would do the opposite, which is to subtract. So you would bring down, I'm drawing this line here, and this line means I'm adding these up. A 5 minus 5 is 0. I don't need to write it. This negative 3x, well, there's nothing under it, so plus 0 is 0. I mean, sorry, it's a negative 3x. Sorry, got a little message there. And then 18 minus 5 would be 13. So what would be the last step here? Well, we said that if there's nothing in between the x and the negative 3, that it's multiplying. The last step then is to do the opposite, which is to divide. I'm representing division with this fraction bar, like I said I would do earlier, right? We said division is just a line. And we're dividing because it's the opposite of multiplication. So we draw our total line again. A negative 3 over a negative 3 is just a 1. But we don't need to write that 1. It stays invisible. So we just cross it out. So it would be a 1x. But we're not writing the 1. Even though it's there, we're just writing 1x, if you will. We're writing the x. And there's one of them. So that's 1x. And then this part of algebra is the easiest part. If that negative 3 can't go into 13, you leave it as it is. If you cannot divide 13 by 3 evenly, if you were to count by multiples of 3, 3, 6, 9, 12, 15. Notice I didn't say 13. I skipped it from 12 to 15. It means that 3 can't go in evenly. Then it's so easy. You just write a 13 over 3. You just leave it like that. So the answer to this is x equals a negative 13 over 3. And I'm not going to even check it right now. I just want to show you the steps, the logical thinking of algebra. Okay, so we did one example. I know it was kind of long. I hardly ever will go this slow in class to explain it. And that's why this video is here for those who need a little bit extra. Okay, what about if there's 2 variables though? And let's say I wanted to solve for y. Well, I'm looking in between the 4 and the y, and I see that there's nothing in between, so I'm multiplying. So the 4 is being multiplied by the y. But there is a plus sign that this 3x is doing to it. So we're always going to undo the addition or subtraction first. So we're going to undo that what's being added. I'm going to do a negative 3x. So another rule is you want to put this negative 3x under whatever you do to one side of the equal sign, do the opposite. So I could put it on this side, but where? Well, since it has an x, and this has an x, I need to put it under the x's. So I shouldn't put the negative 3x under the 16 because it's not a like term. It doesn't have an x. These cancel out. Bring down what you didn't use. So you have 4y equals 2x minus 3x would be a negative 1x. Again, you don't have to write the 1 because there is 1x plus 16. And then what's the 4 doing to the y? There's nothing in between, so it's multiplying. So you do the opposite of multiplying. You divide. The answer is y equals negative. There's a 1 there, even though you don't see it, it's invisible. A 1 over 4x. And notice I'm not just dividing this by 4. I'm dividing this term also by 4. Both terms. 16 divided by 4 is 4. Since 4 can go into 16, you don't write it as a fraction, you write it as the number. 4 goes into 16 4 times. 4 can't go into 1, you write it, it's easy. You just write it, 1 over 4. Okay. The reason we're going to go to divide both terms is whatever you do to one side of the equal sign, you do to the other side of the equal sign. So I can't just do one number or one term. I got to do it to the whole side. If there were more numbers, I would have to divide them all by that 4. Okay, so this would be the answer for y. Okay, so let's do this one. We'll solve for x. And this is one of the things I think does get confusing, this part 1 right here. And that's why I want to do this problem. This one throws people off. Again, you're trying to solve for x. You always want to undo addition or subtraction first. But if you look in between, the 3 and the x, there's nothing in between, so you're multiplying this 3 times the x. But what about this 5? There's a negative between the 5 and the 3x, so you would think, well, I'm subtracting, right? And this is the part that does get a little confusing. This subtraction tells me that I'm either adding or subtracting. I'm either adding or subtracting because there's a negative here, but you have to look in front of the 5 to see what you're doing. So what is so confusing is this negative is telling me what I'm doing, but then I have to look in front of the 5 to see what it is. Well, there's nothing in front of the 5. There's not a positive or a negative. So if there's neither, it's automatically positive. So this 5 is being added to this negative 3x. I could have wrote it like this. It probably would have been easier to tell that it's being added. But that's not how this question is written. So this negative is telling me that I'm adding and subtracting, and this 5 is telling me that it's a plus 5. How do you undo a positive 5? You do the opposite. What did we say the opposite of addition was? The opposite of addition, we said, was subtraction. So we're going to subtract this 5, okay? And the reason you're doing the opposite is because they're on opposite sides of the equal sign. So a negative 5 here and a negative 5 here. Let's draw our line. The 5, take away 5 is nothing. Negative 3x, well, there's nothing under it. We just bring it down. A negative 8 and a negative 5 is a negative 13. And then now there's nothing in between the x and the 3. There's a negative there, but it's not in between the x or the 3. So that just means that if this negative 3 is being multiplied or times by the x, if it was an x minus 3, you'd be subtracting it. But you're not subtracting this because the negative is not in between, it's on the side. So we need to do the opposite because they're on opposite sides of this equal sign. What's the opposite of multiplication? It's to divide. X equals a negative divided by a negative is a positive. Okay. Last one we'll go over today. What if you have a question like this? Again, you have a negative 7. You have this negative in between a number and the 4x. That negative is indicating that you're adding and subtracting, but you have to look in front now to see what you're doing. So this negative is telling me that I'm adding or subtracting something to this whole term, but it's not telling me what I'm doing. And that is what throws people off so many times. It's telling me I'm doing something, but then you have to look in front of this number to see what it is. I'm subtracting the 7. So since it's, how do you undo a subtraction? Well, you do an addition. And the reason you're adding is they're on opposite sides of the equal sign. Bring down the negative 4x equals 15. Now what's the negative 4 doing to the x? Well, there's nothing in between the negative 4 and the x, so it's multiplying. So you do the opposite and you divide. X equals 15 over 4 negative. Okay, anyway, I purposely cover these things because I've seen so many students who even think logically, think algebraically, miss some of these things by the way they look. So I wanted to kind of give you a frame of how to think about it. I hope it's helpful.